Hi learners, today we are going to see about types of attacks. Attacks are of two types. First one passive attack, second one active attack. So what is meant by passive attack? Passive attacks are those wherein the attacker indulges in eavesdropping on or monitoring of data transmission between the sender and receiver. So a passive attack attempts to learn or make use of the information from the system but does not affect system resources. The attacker aims to obtain information that is in transit. The term passive indicates that the attacker does not attempt to perform any modification to the data. Passive attacks are of two types. First one, release of message contents. For example, a telephone conversation, an electronic mail message, and a transferred file may contain sensitive or confidential information. We would like to prevent an opponent from learning the content of this transmission. Second one, traffic analysis. Masks the contents of messages so that opponents could not extract the information from the message. Passive attacks are very difficult to detect because they do not involve any alteration of data. It is feasible to prevent the success of attack, usually by means of encryption. Then let's move on to the next attack, active attack. Active attack involves some modification of data stream or the creation of a false stream. These attacks cannot be prevented easily. Active attacks can be subdivided into four main categories. First one, masquerade. Second one, replay. Third one, modification of message. Fourth one, denial of service. Masquerading takes place when one entity pretends to be a different entity. Replay involves the passive capture of a data unit and its subsequent retransmission to produce an unauthorized effect. Modification of message involves some change to the original message. It produces an unauthorized effect. Denial of service prevents the normal use or management of communication facilities. Fabrication causes denial of services DOS attack. Let's move on to the next topic, types of wireless attacks. The main categories of attack on wireless computer networks are: first one, interruption of service. Resources become unavailable because it is destroyed. Second one, modification. An attacker gains access of the resource or modify the database values and alters the program, etc. Third one, fabrication. The attacker sends fake message to the neighboring nodes without receiving any related message. Fourth one is jamming. Jamming is a special class of denial of service attack which are initiated by malicious node after determining the frequency of communication. In this type of attack, the jammer transmits signals along with the security threats. Jamming attacks also prevents the reception of legitimate packets. Fifth one, attack against encryption. Weird equipment privacy encryption method has used 802.11b wireless LAN, but there is some weakness in this algorithm. Sophisticated attacker can break the WEP methods. The next one, misconfiguration. Because of heavy load on the network, most of the access points are not configured properly. These attack points remain at high risk of being accessed by unauthorized parties or hackers. Next one, interception. As the communication takes place on wireless medium, can be easily interrupted with the receiver tuned to the proper frequency. The main aim of such attack is to obtain the confidential information that should be kept secret during the communication. The information may include private key, public key, location or password of the nodes. Wireless Equipment Privacy Protocol (WEP) is a security protocol specified in the IEEE Wireless Fidelity Wi-Fi standard 801.11b that is designed to provide a wireless local area network WLAN. WEP is designed to provide the same level of security as that of a wired LAN. The web algorithm was designed to use it to protect wireless communication from unauthorized eavesdropping and restricting access to a wireless network. A wide local area network LAN is generally protected by a physical security mechanism that are effectively for a controlled physical environment. Because a wireless network broadcasts message using radio, it is particularly susceptible to eavesdropping. Then, WEP aims to provide security by encrypting data over radio waves so that it is protected as it transmitted from one point to other. However, WEP is not as secure as believed. WEP is used to lower two lower layers of OSI model, the data link and the physical layer. It therefore does not offer end-to-end security. Standard 64-bit WEP uses a 40-bit key which is concatenated to a 24-bit initialization vector IV to form the RC4 traffic key. But restrictions on cryptographic technology limit the key size. Once the restrictions were lifted, all of the major manufacturers eventually implemented an extended 128-bit WEP protocol using the 104-bit key size. Key size is not only the major security limitation in WEP. Cracking a longer key requires interception of more packets, but there are active attacks that stimulate the necessary traffic. Thank you.